Okay. Hello, everybody. Thank you for joining the Revelation BNB Hackathon. I'm Nathan here from Animoca brands. So the session is quite short, so I will kind of skip the intro. But if you don't know Animoca brands yet, we are a major group in the blockchain and gaming space with a lot of exciting projects such as Rev, the Sandbox, or Phantom Galaxies. Please go take a look if you're interested. So today's topic is going to be very technical. We're going to talk about a very common use case of blockchain and smart contracts, which is escrowing. So escrowing is a very common need for different type of logics. So one definition can be is temporarily transferring the ownership of some assets to a smart contract called the escrow. The asset is then to be released under specific conditions later. So since very long time already, we can see the usage of escrowing in secure swaps, where you would escrow an asset until your counterpart also escrows it. Then you would securely swap your assets with someone thanks to the escrow. Another use case, which is also very common, is staking, where you would put your asset in escrow in exchange for dividends, which would be distributed over time. Other use cases, which are like kind of very sexy nowadays, would be lending and rental. So lending, very simple. You would escrow your asset while you give the right of usage to a third party. And the rental would be more or less the same logic. You lock your asset and you give the right of ownership to someone else, but this time in return of some rent that they would pay. So the potential problems here, which can rise when escrowing, would be, first of all, say, let's talk about NFTs. So if your NFT is escrowed in a contract, you escrowed it, and then who is the owner? So this would not be a straightforward answer, as there is no standard way to know it. So a contract itself could implement a function which would allow any third party to know it, but this is not standard. And one problem based on this, which actually has already happened, so I think it's good to mention it here, is sometimes you have projects which will airdrop some types of new assets when to the owners of an existing asset. Say everybody who has these tokens will be able to get an airdrop of our new NFT. But if these tokens are actually escrowed, then the owner, the actual real owner, will be the escrow itself. And it has happened that in the end, this airdrop would be sent to the escrow, which doesn't actually have a way to manage it. So that can be problematic. Then another issue will be, okay, I escrowed my token, but I would like to transfer ownership. Can I or can't I? So in the normal use case, since you lost the ownership of your token, you cannot actually transfer their ownership. So think of this use case. You're renting out a token, and you have a sort of contract with your tenant that this will be rented out for a year, and you will get, say, a monthly rent for that. But then you would like to be able to actually sell your token with the lease attached to it. This is something which is usually not managed. Another issue which there have been some attempts to solve through some standard proposal is who is the user, meaning who is in the case of delegation, lending, rental, who is actually allowed to use the token, even though they are not the owner of it. So I put this one in parentheses because this is not in the scope of this one in parentheses because this is not in the scope of this current talk and this current design proposal. So let's go to see a high level of a solution that we propose to actually solve the previously mentioned problems. So at the moment, you will escrow a certain token, say token X, you will send it to the escrow contract. And the escrow contract will actually mint back a token to you that we're going to call X prime. And then later, when you will want to unescrow your token, then you will burn the token X prime and get back the ownership of the original underlying token X. If you see here, actually, you see that user wallet A was escrowing the token, but later on, this is user wallet B, which burns token X prime, which means that in the meantime, X prime can be transferred between wallets. So what did we solve? So the previous problems. So who is the owner? The answer would be either the owner of X prime, if X prime exists, else the owner of X. And about ownership transfer, yes, you can actually transfer X prime. So now the question is, how could we make a standard out of it? So we are going to rely on three types of factors with distinct responsibilities. So the pillar would be the register of deeds. So deeds here means these sort of X prime tokens, right? So the mission of the register of deeds is to trustlessly centralize the token escrowing or unescrowing requests from escrow agents, which will come right after. So this is a contract, it's a registrar, so it's uniquely deployed per network. What it will do is it will deploy a deed token, which is like this kind of X prime container. So a deed token contract for each of the underlying contracts that you will want to escrow. So say I want to escrow a Bored Ape NFT token, right? So the register of deeds would deploy an equivalent NFT contract, which would be Bored Apes prime, and make the mapping between these two contracts, these two NFT contracts, publicly available. Then it will escrow the tokens on the behalf of the escrow agents and deliver the Bored Ape prime if you escrow Bored Ape. And finally, on token destruction, as we've seen before, it will release the ownership of the token to the last known deed owner. Okay, that's it for the register of deeds. Then let's look at the escrow agents. So their mission, so think of it, the escrow agent, say, let's take the example of a rental contract. So the rental contract itself would be the escrow agent. And its mission will be to interface with the register of deeds and to handle the logic for deed token transfers. So it can be staking, rental, delegation, any sort of application that would normally escrow your token. It handles escrowing and unescrowing requests, which are coming from the users through their wallets. And importantly, it will handle through a callback the transfer logic coming from the deed tokens. And important point, it implements access control based on the ownership of the deeds. So say when you will want to unescrow your token, you need to be the owner of the deed. So this is this type of access control we are talking about. And the deed token, the mission is to represent the ownership, so they are the prime token. So they represent the ownership of the underlying token. They're deployed by the register of deeds. The minting burning can only happen in the scenario of an escrowing or an escrowing, it mimics the escrow token, for example, with identical token ID and metadata, and it notifies the related escrow agent on token transfer, which is what I just explained. So now let's look at a flow, an example flow for a staking contract. So wallet A would approve the agent to transfer its tokens. Then it will call the function stake, X being the token that it is wanting to stake. The escrow agent will call a safe transfer on the token to actually transfer it to the register of deeds. So at this moment, the transfer happens, transfer X from wallet A to the register of deeds. And through reception callback, the register of deeds will then execute a logic. First time that this particular ERC-721 token is staked, then the deed token, so the prime token, will be deployed, and the mapping between the token and its deed will be registered. Then it will mint the token the token X, which X being the token identifier, but which is the same as the token X. It will mint it to the wallet A. So at this point, the minting of X prime happens, and it is given to A. So that is the initial stake flow. Then in the case of usage, so we have two use cases here. These are two separate transactions. This here is all going in one transaction. So here, the first transaction shows when the wallet A will want to transfer X prime to wallet B. So we'll call the transfer from on the deed token, which will transfer effectively the token to wallet B and call a specific on deed transfer callback to the escrow agent. So here, as an example, we are in the staking contract, so there are outstanding dividends. So at this moment, this staking contract would take care of distributing the outstanding dividends to A at the right before the B will take it over to be the beneficiary of the dividends. Then later on, the wallet B, so more dividends have accumulated, and wallet B wants to withdraw the rewards. So it will call the escrow agent, call this function called withdraw rewards. And the escrow agent would ensure, by calling the owner of this deed token on X, would ensure that B is actually the legitimate owner of the deed, and then can go on to distributing these new outstanding dividends to B. And finally, the flow for unstaking. So now wallet B is still the owner of X prime. So it will call an unstake for token X on the escrow agent. The escrow agent will ensure that B is a legitimate owner of the deed, then will request the register of deeds to destroy X. The register of deed will check again who is the owner of X, then burn X, and finally transfer the token which it had escrowed to the owner of X, which was B. So it's transferring the token from the register of deeds to B and token X right after the burning of X prime happened. And so finally, the register of deeds gives back the token ownership. So the advantages are permanent transferability. So you can sell a token while it is being rented out, for example. You can transfer a stake token without interrupting the dividends flow, as we just saw in the flow example. It is standardized. Escrow agents just need to implement a standard interface. And on-chain and off-chain processes know the ownership configuration at any moment. So basically safeguarding the problem with the airdrop that I mentioned earlier. It is totally retrocompatible. It works with any existing and future token standards. Would it be ERC20, 721, 1155? 777 and others. And it is 100% compatible with any deployed token contract, since no extension, no modification is required on those. And it is also non-limitative. It's only take care of the ownership management. So say in the case of a rental or a lending contract, you want to take care of the usage rights, you can still do it. You could have the escrow agents implement another standard, maybe minting another token, which represents the usage right. It is free. I mean, nothing limits this kind of other use cases through this standard. And that's pretty much it. Thank you for your attention. I hope you will enjoy the concept. If you want to know more, you can visit our website, the Animoca Brands website, our GitHub, and we have a reference implementation for the deeds, for the register of deeds, in the case of ERC 721, right here. So I think these links should also be in the description of the YouTube video. And I think we're done. Thank you very much.